Please like, share, and subscribe. Wishing you happiness and good luck every day.
What if everything we thought we knew about algorithmic trading is just wrong? What if that hunt for the one perfect, money-printing strategy is a total waste of time? Well, that is the really provocative idea from system architect Victoria Dolzhenko that we're going to get into today. It's this total shift in mindset from being a treasure hunter to becoming an engineer.
Okay, so it really all boils down to this one big question, right? Can a robot, a cold, calculating piece of code, actually trade better than a human? I mean, can it outsmart us in the super high-stakes emotional battlefield of the financial markets? This is the question that fuels a multi-billion-dollar industry, and believe me, the answer is, well, it's not simple at all.
I mean, think about it. On one hand, you've got the human brain. It's amazing, right? It can make these incredible leaps of intuition, see patterns a machine would just totally miss. But it's also hardwired with fear and greed. And those two emotions have probably destroyed more trading accounts than anything else in history. Then you've got the other side, the algorithm. It's lightning fast, feels zero panic, no FOMO, it just follows the rules, period. But that's a double-edged sword, isn't it? It can't improvise. And at the end of the day, it's only as smart as the person who built it. Okay, so let's say you're sold. You're ready to bring in a machine to help you trade. Well, now you're at a crossroads. Turns out there are really four main paths you can take into the world of algorithmic trading, and they range from something super simple, like just buying an off-the-shelf solution, all the way to building your very own system from scratch. So, path number one. This is the easy one, just buying a ready-made solution. You've probably seen these, right? Trading signals that pop up on your phone, these so-called expert robots that promise to trade for you, or even services that just automatically copy the trades of some professional. It's definitely the quickest way to get in the game, but you gotta know, it comes with a huge flashing warning sign. And this is where this quote from the author just hits the nail on the head. You have to stop and ask yourself a really simple, logical question. If this robot is truly a machine that prints money, why on earth would someone sell it to me for a few $100? That's a critical piece of skepticism you have to carry with you. All right, the next couple of paths, these give you a bit more control. You could use one of these no-code platforms. They're kind of like Legos for trading, You just snap together these pre-built blocks of logic and build your own simple robot. Or, if you're more of an idea person and not a coder, you can always hire a developer to be your architect to take your unique trading blueprint and build it for you. And that leads us to the final path. Path number 4, complete and total independence. We're talking building your own system from the ground up. Now, this is by far the hardest route, for sure, but it gives you absolute freedom. I mean, you want to test some wild theory that a stock's price is tied to social media mentions or, the weather? With your own platform, the sky's the limit. You can test literally anything you can dream up. Okay, this is where we get to the really big idea. The most powerful and, honestly, counterintuitive concept in this whole approach. It challenges the one goal that pretty much everyone in algorithmic trading has been chasing for decades. See, for most traders, their entire career is like a treasure hunt, right? They're searching for that one single perfect holy grail strategy, that secret formula that's going to make them 1,000% return and solve all their money problems forever. It's this epic, lifelong quest. But this is where the author, with her engineering background, steps in and asks this brilliant question. What if that's the wrong quest? What if we've been going about this all wrong? What if instead of being treasure hunters, we should be thinking like systems engineers? And boom, that right there illustrates the core idea perfectly. Stop hunting for that one mythical, super profitable unicorn strategy. Instead, build a system designed to automatically find and manage hundreds of reliable, good but not great workhorse strategies. Your probability of success just goes way, way up. So this is the huge mental shift, right? Stop searching for that one golden needle in a massive haystack. Instead, build a machine that can just process the entire haystack and pull out hundreds of little valuable pieces of straw. The goal isn't a lottery ticket win anymore. The goal is to build a diversified, robust portfolio based on lots and lots of small, consistent wins. All right, so if you're going to manage hundreds of strategies instead of just one, you obviously need an incredibly solid foundation. You need a rock-solid system. And according to our source here, every single successful trading system, doesn't matter if it's simple or super complex, is built on 3 essential non-negotiable pillars. These are the three big questions your system absolutely has to answer. First, you've got your trading theory. Think of that as your offense. It tells you when to attack the market. But then you have capital management and risk control. That's your defense. They decide how much you risk on each attack, and maybe most importantly, when to pull back. And listen, if you only have an offense, you're not a trader. You're just a gambler.
So let's talk about Pillar 1, your trading theory. It all starts with the most basic question you can ask. What is the market actually doing right now? Is it trending up? Is it trending down? Because that's where momentum strategies work best. Or is it just kind of stuck, going sideways in a range? Because that's a totally different environment. The single biggest mistake you can make is using the right strategy and the wrong market condition.
Now this is a look under the hood. We're looking at the market's raw engine here, the order book. This isn't some chart of what happened in the past. No, this is a live look at what traders intend to do in the future. You can literally see these walls of buy orders and sell orders, and it gives you this real-time map of supply and demand. For an algorithm, data like this is pure gold.
But look, even the best trading theory in the world is totally useless without the other two pillars. And these are all about one thing: survival. It's about managing your money and controlling your risk. If you get these two things wrong, you're not trading. You're just taking a very, very expensive trip to a digital casino.
One of the biggest decisions your system has to make is how big your positions should be. And you've got two completely opposite philosophies here. On one side, you've got the martingale strategy. That's where you double your bet every single time you lose. It's a really dangerous game of chasing your losses. The complete opposite is the anti-martingale. That's where you increase your bet after you win, basically pressing your advantage when you're on a hot streak.
And the author gives a really stark warning about that martingale approach. Why? Because a long enough losing streak isn't just possible, it's a mathematical certainty. It will happen eventually. So this strategy is a pretty much guaranteed path to blowing up your entire account. It just can't survive that inevitable string of bad luck.
So this is where you build your fortress, your defense. You need to have financial guardrails that are totally non-negotiable. I'm talking hard-coded rules, like a maximum loss for the day that just shuts the whole system down, a stop-loss order on every single trade, and of course, diversification across a bunch of different strategies. These aren't suggestions, you know? They're absolute laws designed to protect you from your worst enemy, yourself.
So at the end of the day, if there's just one thing you take away from all of this, let it be this. You have to reframe your entire approach. Stop being a treasure hunter who's searching for some mythical magic map. Start thinking like an engineer. Design a system, test all the little components, measure your results, and then continuously maintain and improve it. It's a process, not some prize you win. And that kind of leaves us with one last big thought to chew on. What if the real secret, the ultimate edge in the markets, isn't finding the perfect answer, the perfect strategy? What if it's about building the perfect system to ask the right questions? A superior process for discovering and testing and managing hundreds of different strategies. Now that's the core idea behind this whole new way of thinking.
Welcome to The Explainer. All right, today we are tackling a huge question for any trader. How do you take that great idea in your head and turn it into a real, working, automated trading system?
You know, it's the ultimate challenge, right? You get this flash of inspiration, this brilliant idea, but the path from that little spark to a fully functioning algorithm, man, it can feel super daunting. So in this explainer, that's exactly what we're going to do. We're going to map out that territory for you.
Okay, so before you dive in and start writing a single line of code, it's really crucial to, understand the landscape. Why? Because someone might have already built the exact tool you need. Yeah, let's think of this whole thing like a ladder of complexity. Every rung you climb up gives you more control, for sure, but it also means more challenge and a lot more work. So we're going to start right at the bottom, on the very first rung, the one that requires the least heavy lifting from you.
All right, let's jump right into our first and, honestly, most accessible path using off-the-shelf tools to get you up and running fast.
So this first path, it's all about ready-made solutions. Think of it like buying a car engine that's already built. We're talking about things like trading signals or buying third-party algorithms. You'll hear them called robots a lot, that are basically ready to go right out of the box. A trading signal is incredibly simple at its core. Some provider, could be a seasoned analyst, could be another algorithm, just sends you a direct instruction. It might be a text message that just says, hey, buy Tesla at 203, target 208. That's it. You're basically outsourcing the entire decision-making process. And what's really interesting here is the whole spectrum of control you can give up. On one end, you've got a simple text alert that you have to act on yourself. Then you move up to something like copy trading, where another account's moves are just automatically mirrored in yours. And then, at the far, far end of the spectrum, you've got full account management, where you literally hand over the keys to the kingdom. And this brings us to the fundamental trade-off, right? The big pro is speed. I mean, you're up and running almost immediately. But the con, and it's a big one, is that the logic is usually a total black box. You have no idea why that signal was generated, which means you're now stuck constantly analyzing the providers themselves to make sure they're still any good. Okay, so moving beyond just signals, you can actually buy an entire piece of software, a robot that executes trades for you automatically. Now, I know, that sounds like the holy grail, right? But this path comes with a major, flashing, red warning sign. Here's the crucial point, and you always need to ask yourself this. If this robot is some magical money-printing machine, why on earth would someone sell it for a few $100? Why wouldn't they just run it themselves and make millions? You've got to be skeptical. Now, within this whole world of off-the-shelf robots, there's one particular system that our source material says you need to be extremely cautious of. It's called the martingale strategy, and on the surface, it sounds kind of tempting. You lose a trade, you just double down on the next one. Win that one, and bam, you've covered your loss and made a profit. So what's the problem? Well, the problem is that a long losing streak isn't just possible, it's pretty much inevitable. And when that happens, doubling your position size will absolutely obliterate your account with terrifying speed. Okay, let's climb up to the next rung on our ladder. This path is really for those of you who want more control, you have your own ideas, but maybe you're not a professional programmer, at least not yet. So on this path, you're using specialized online services that pretty much act as a constructor or a builder's kit. They give you the whole framework, all the data feeds, the connections to brokers, the testing environment, everything. This lets you focus on the fun part, building a robot's logic, without having to get bogged down in deep programming. And the process is actually really empowering. You can use a visual drag-and-drop builder to lay out your strategy, maybe combine a few technical indicators, and then, and this is the cool part, the service lets you instantly back-test it against years and years of historical data to see how it would have performed. And if you want to get a little more advanced, a lot of these platforms offer simplified scripting languages so you can build out more complex logic. Honestly, this is a fantastic middle ground. You get to bring your own ideas to life, and you often get access to a whole community of other builders. But what's the downside? Well, you're ultimately playing in someone else's sandbox. If you want to use a weird data set the platform doesn't offer, or some obscure indicator they haven't built in, you're just out of luck. Your creativity is basically limited by the tools they give you. All right, we've made it. We've arrived at the very top of the ladder. This is the most demanding path for sure, but it is also by far the most powerful, building a completely custom solution from the ground up. On this path, there are literally no limits. You are the architect. You're in total control. But right away, the path splits into two very different directions. You either roll up your sleeves and develop the whole thing yourself, or you hire a professional to build your vision for you. And this is where you really see the power of a custom approach. Got some wild theory? Like, what if you could correlate stock prices to social media sentiment? Or, I don't know, even weather patterns? With a custom build, you can actually create a system to test that stuff. This path becomes less about just trading and more about pure research and development. Truly, the only limit is your imagination. And this table here lays out the choice perfectly. It really boils down to time versus money. Building it yourself costs your time, and believe me, a lot of it, but you get maximum control and zero risk to your intellectual property. On the other hand, hiring developers costs cold, hard cash. It demands you have sharp management skills to keep the whole project on track, and it introduces that big risk that your brilliant idea could get leaked if you don't have ironclad contracts in place. So there we have it. We've climbed the whole ladder, from buying a pre-built engine to assembling a kit, all the way to designing your own from scratch. With all these options on the table, how in the world do you choose the right path for you? Well, the truth is, the right path really depends on your skills, your budget, your commitment, all that stuff.
But our source material offers a really fascinating shift in mindset here. Instead of spending all your energy hunting for that one perfect strategy, the holy grail of trading, it proposes a completely different goal.
And this is such a powerful idea. Forget about searching for that one single strategy that's going to return 1,000% a year. What if, instead, you built a system that could find hundreds of small, reliable strategies, each one with just a modest return? Think about it. Diversifying across hundreds of small wins could build something way more robust and consistent in the long run. Ultimately, look, there is no single right answer here. But now you have the map. You understand the territory. So whether you buy an engine off the shelf, assemble a kit, or engineer your own from the ground up, the journey starts right here with knowing your options. So the real question left is, what kind of builder will you be? All right, today we're doing something pretty cool. We're going to build a trading robot right from scratch. We'll walk through the whole thing, step by step, from the absolute basics of how markets work, all the way to the strategies that actually make a system tick. So let's just dive right in. I mean, that's a pretty big question, isn't it? Could a robot actually trade better than you? But it really gets to the core of why people even bother with automated trading in the first place. As humans, we get caught up in fear, greed, maybe a little hesitation. A robot? It doesn't feel any of that. It just does what you tell it to do perfectly every single time. And that is the key, right there. This isn't about some secret magic algorithm. It's all about building a solid, really well thought out system. So the question isn't really, can a robot trade better than me? The real question is, can I design a system that gives it the power to? Okay, so before we can start building, we gotta understand the world our little robot's gonna live in. It needs to speak the language, So let's cover the fundamental lingo of the market, starting with the real basics. First things first, the exchange. You can just think of this as the big, central marketplace. It's where all the action happens, where buyers and sellers meet up to trade, well, pretty much everything. Stocks, bonds, currencies, you name it. So when you're ready to actually make a trade, you have to place an order. The simplest one is a market order. This is basically your get this done right now button. You're telling the system to buy or sell immediately at the best price available in that split second. The key here is speed. You're prioritizing getting the trade done over getting a specific price. Then you have the limit order, which is kind of the opposite philosophy. This is your get it done, but only at my price command. You set the exact price you're willing to buy or sell at, or a better one, and if the market never hits your price, well, your order just sits there, patiently waiting. It might not ever get filled. So where do all these patient limit orders go to wait? They hang out in something called the order book. Just imagine a big live list. It's basically a real-time picture of all the supply and demand, with all the buy orders stacked up on one side and all the sell orders on the other, all neatly organized by price. And this is where you see how these two types of orders work together. It's really cool. When a market order, that's our get it done now order, comes in, it doesn't wait around. It just jumps into the order book and instantly starts eating through the best priced limit orders it can find until its entire order is filled. It's like this constant dance between people who want speed and people who want a specific price. Okay, so now that we've got the basic lingo down, we can get to the really important part, the robot's brain. This is the core strategy, the trading theory. It's the whole philosophy that's going to guide every single decision our robot makes. There's a great quote in our source material that says, "A trading system without a quality theory is like trying to grow a plant without a seed." I love that analogy. Your trading theory is the seed. If you don't have a strong, clear idea at the very beginning, your system just has no chance of ever growing into something profitable. So what kind of seed do people usually plant? Well, for a lot of people, especially when they're just starting out, the go-to choice is technical analysis. And why is that? It's because it's visual. You're literally looking at price charts, checking out trading volume, and trying to spot patterns that might predict what's going to happen next. It's just a really accessible but still powerful way to get started. And the main tools of the trade here are, you guessed it, charts. You've got all kinds. Candlestick charts, bar charts, line charts. They all show the same basic thing, how the price has moved over time, but they just visualize it in different ways. Each one is designed to help you spot certain kinds of patterns or trends a little more easily. So when you're staring at one of these charts, what are you even looking for? Well, the absolute most fundamental goal is to figure out the trend. Is the market going up? Is it going down? Or is it just kind of bouncing around sideways? Answering that one basic question is the first step for pretty much any technical strategy you can think of. All right, so we've got the brain for our robot. Now we need to give it some discipline. I mean, you can have the most brilliant strategy in the world, but it's totally useless if you blow all your money on a couple of bad trades. That's where money and risk management come in. These aren't just rules. They're the rules for survival. And seriously, don't sleep on this part. The source material tells this, well, it's a pretty scary story about an experienced trader who lost 70% of his capital. 70%. On just 4 trades where he went way too big. It's a perfect example that shows success isn't just about being right. It's about surviving long enough for your strategy to work. When you get right down to it, that's what capital management is all about. It's a system that answers one simple but incredibly important question. How much money should I bet on this one trade? It's all about picking the right size so that one single loss can't just knock you out of the game for good. Now, there are a ton of complex theories on this, but a lot of them come down to 2 really different philosophies. First, there's the martingale strategy. This is where you double your bet every time you lose. The author of our source material gives a huge warning about this one because, well, you can imagine, a bad losing streak can wipe you out super, super fast. Then there's the opposite, the anti-martingale. Here, you only increase your bet size after you win when you're on a hot streak. Okay, and probably the single most important tool in your risk control toolbox is the stop-loss order. Think of it as your automatic, pre-planned exit strategy. It's a safety net. Before you even get into a trade, you decide the absolute maximum you're willing to lose, and you set an order that kicks you out automatically if things go south and the price hits that level. Let's make this super simple. Say you buy something because you think the price is going to go up. You would set your stop-loss order at a price below where you bought it. This basically creates a safety floor. If you're wrong and the price starts to drop, bam, your stop-loss triggers and sells for you, capping your loss before it gets any worse. And the exact same logic works in reverse. If you're selling short, meaning you're betting the price will fall, you place your stop-loss above your entry price. Now it's a protective ceiling. It's your escape hatch in case the price suddenly spikes up when you were expecting it to go down. So, we've walked through the core pieces needed to build our trading robot. We have the language, the brain, the discipline. But what's the real point of all this? What's the system's true goal, its never-ending mission? So let's just recap the whole architecture we've put together. We have these 4 essential pillars. We've talked about having a clear trading theory, that's the brain. We've covered smart capital management and strict risk control, that's the discipline. Now the 4th pillar, which is a massive topic all on its own, is testing. You have to make sure all 4 of these pillars are working together perfectly to have any chance at a stable system. And this really brings us to the ultimate goal. The point isn't to build one single perfect system, set it loose, and just let it run forever. That's not how it works. Markets are always changing, so your system has to evolve too. The real mission, your guiding star, as the source puts it, is the constant, never-ending process of improvement. So, there you have it. We've laid out the complete blueprint. Our robot is, conceptually at least, built. But this whole idea of continuous improvement, it leaves us with one final, pretty deep question to think about. If the whole point is to keep evolving, is the job ever really, truly done?
Ever stop and think about how a machine actually learns to trade? To make money all by itself? It might seem like it's some kind of black magic, but really it all comes down to architecture. So let's dive in and break down the complex design of one of these algorithmic trading systems, piece by powerful piece.
At the heart of it all is this one question that sounds so simple, but trust me, it's anything but. How do you take a very human, very vague goal like, I want to make money, and translate that into the cold, hard, unforgiving logic of a computer program? That is the real puzzle we're going to unpack today.
The whole thing really kicks off with a conversation. It's this back and forth between, say, a client who has this big abstract dream and the system architect who has to somehow turn that dream into a functioning reality.
And this is pretty much exactly how that conversation goes. The architect asks, okay, what's the purpose here? What do you want this thing to do? And the client gives this perfectly logical, but completely technically useless answer. To make money. As much as possible. And that's where we begin, with this huge goal, but absolutely no roadmap on how to get there.
All right, so how do we get from make money to a real working system? Well, you've got to break it down. We have to deconstruct the whole idea into its smallest, most fundamental parts. Let's start with the first building block.
So the most basic piece of the puzzle is something called an indicator. Just think of it like a sensor for the market. It takes in this flood of raw data, prices, trading volume, news headlines, and it boils all of that chaos down to a single meaningful number. So like a super common one is the 50-day moving average. All that does is tell you the average price over the last 50 days. That's it. It's just one number that kind of sums up the recent trend.
Yeah, and this visual just lays it out perfectly. You see all that messy, raw data going in one side, and what comes out the other is this one clean, simple number. This number is what tells us something very specific about what the market is doing right now.
Okay, but one number by itself, that doesn't really tell you what to do, right? That's where the signal comes in. A signal is basically a little decision maker. It takes the numbers from one or more of those indicators, and it asks a very simple question that can only have a yes or no answer. So, sticking with our moving average example, a signal might ask, hey, is the current price more than, say, 1% higher than that 50-day average? And the answer can only be yes or no. That's it. Buy or stay put.
And check this out. The really cool part here is that box labeled Some Magic with Indicators. I love that because that magic is the core of the signal. It's just the set of rules we created, like our is the price 1% above the average question, that turns those raw numbers into a clear, actionable command. Go or no go.
All right, so let's put these pieces together. We combine these building blocks into a complete strategy. See, a full-blown strategy is way more than just a buy signal. It's the whole playbook, right? It's got a signal to get in, sure, but also a signal to get out. Plus, it has rules for how much money you're going to risk and exactly when to cut your losses or take your profits. It's the whole shebang.
And this is a really, really important distinction to get, the difference between a theory and a strategy. A theory is just the general idea, the blueprint. For example, buy when the price crosses above its moving average. Okay, cool. But a strategy has to get specific. Are we talking about a 20-day average or a 200-day? And does the price have to cross by a penny or by 2%? Every single one of those specific choices creates a totally unique, testable strategy, all from that one starting theory.
And this is where things get really wild. This brings us to what's basically a strategy factory. This is where the system takes a single good idea, a single theory, and starts exploring the absolutely massive universe of possibilities that it holds. Yeah, this diagram just nails it. The user comes up with one core idea, one theory, and the system just takes it and runs, spitting out this huge army of unique strategies, just by fiddling with all those little knobs and dials we talked about, the length of the average, the percentage trigger, how much risk, all of it.
So you get the picture. The system grabs the blueprint and just starts churning out different combinations of all those parameters, but that raises a pretty massive question, doesn't it?
And here's the problem. This numbers game gets out of control, and I mean fast. What seems like a lot of possibilities just explodes into a number so huge it's basically impossible.
So your first thought is probably, okay, simple. To find the best one, we just test every single possible combination, right? Just a classic brute force attack. Let the computers run and pick the winner. Easy. But hold on. Let's really think about that for a second. For just one pretty simple theory, with just a few knobs to turn, how many combinations are we really talking about here? Yeah, that many. That's 3.07 with 35 zeros after it. That number is it's mind-boggling. We're not talking millions or billions or even trillions. And remember, that's just for the signal to open a position, just one part of the strategy. So to really wrap your head around that number, if you tried to test every single one of those combinations, even on a monster supercomputer cluster, it would literally take millennia. We're talking longer than all of recorded human history. So yeah, the brute force idea, it's not just a bad idea. It is completely, fundamentally impossible. Okay, so if brute force is off the table, we can't work harder. We have to work smarter. And this is where our hero rides in to save the day. Optimization.
So what are optimization algorithms? Well, think of them like highly intelligent search parties. They're specifically designed to explore that insane landscape of possibilities and find the treasure without having to check under every single rock.
And the way it works is actually this beautiful, simple loop. Step 1.
The algorithm suggests a set of parameters, kind of like making an educated guess. Step 2, the system backtests that specific strategy using historical data. And then step 3, the most important part, the results of that test get fed back to the algorithm. It learns from what happened, what worked, what didn't, and then it makes a new, even smarter guess for the next round. It just keeps repeating that loop, getting better and better each time.
And look, this is probably the biggest takeaway of this whole thing. The goal of optimization is not to find that 1 in a trillion single perfect strategy. That's a fool's errand. The real goal is to find a damn good one that's really profitable and stable, and to find it in a reasonable amount of time, before the sun burns out. It's about finding what's practical and powerful, not what's theoretically perfect.
Which brings us to one last really interesting question to chew on. What does good even mean in this context? Is the best strategy the one that's like a home run hitter, swinging for the fences and occasionally hitting a massive winner? Or is it the one that's just consistently getting on base day in and day out, delivering steady, reliable results over time? And honestly, that question, that's the real puzzle at the heart of designing any trading strategy.
All right, today we are getting into the guts of an automated trading system. We're going to pull back the curtain and look at the actual architectural blueprint, all the big decisions you have to make to build a machine that can trade in the financial markets completely on its own. So let's get into it.
So here's the big question we're trying to answer. What does it actually take to architect a system that's not just smart, but also tough, scalable, and can bounce back from problems? What's the master plan for something that can find profitable strategies and then execute them without a single hiccup? Like any massive project, it really all boils down to one single foundational choice that sets the stage for everything else that comes after. And that choice, that first big fork in the road, is whether you build a monolith, which is basically one giant all-in-one application, or if you go with a microservices architecture, which is more like a team of small, independent programs all working together. And this visual really says it all, doesn't it? On the right, you've got the monolith. Think of it like one giant complex engine, where every single part is bolted to every other part. But on the left, you've got microservices. That's more like a fleet of smaller, specialized cars, each with its own driver, all coordinating to get to the same destination. Let's break that down a little more. A monolith is tightly coupled. That's a fancy way of saying a change in one tiny part can cause unexpected problems everywhere else. It's predictable, for sure, but it's also really rigid. Microservices, on the other hand, are loosely coupled. They talk to each other, but they don't depend on each other's internal wiring. They're built for flexibility. So for this trading system, microservices were the obvious choice. And why is that? Well, independence is a huge deal. You can roll out an update to the part that's looking for new ideas without ever having to touch the part that's actively trading with real money. You can also scale just the pieces you need to. If your strategy engine is working hard, you can give it more horsepower without beefing up the whole system. And you can run different parts in different places, do the heavy-duty testing on some cheap PCs at home, while the live trading is humming along on super reliable servers in the cloud. And this quote right here, this is the whole ballgame. It gets right to the heart of it. When you're dealing with real money, you absolutely positively cannot risk having a new software update accidentally crash the part of the system that's actually managing your portfolio. That real trading block is sacred ground, and a microservices approach is what protects it. Okay, so you've picked microservices. Awesome. But now, instead of one big application, you've got maybe dozens of tiny little applications to keep track of. How do you stop that from turning into complete and utter chaos? Well, you put them in containers. You know that classic developer excuse, well, it worked on my machine? Containers are what finally solves that problem. A container is basically a standardized box that has your app and everything it needs to run, all packaged up inside. That means you can take that box and run it anywhere. Your laptop, a server in your basement, a giant cloud computer, and it's going to work exactly the same way every time. But even with these neat little boxes, updating things can be a pain. I mean, look at this manual process. You have to start up the new version, switch the traffic over, then shut down the old one. There are just so many steps where a simple human mistake could bring everything crashing down. And that is where an orchestrator like Kubernetes comes into the picture. Honestly, think of it as the project manager for all your containers. It completely automates that whole scary update process we just saw. It handles scaling things up or down, and basically keeps an eye on all your little microservices to make sure they're healthy and happy. It's what makes this whole approach actually manageable. Okay, so we've got our architecture and the tools to manage it, but how does this system actually get any work done? How does it split up the massive job of finding and then executing trades? At the very highest level, the system is really cut in two. You've got the strategy search subsystem, which is like the brains of the operation. It's constantly digging through data, looking for profitable new ideas. Then, whenever it finds a promising one, it hands it off to the real trading subsystem, which is like the hands. It's the part that actually places the trades. So let's think about a real-world problem here. A user clicks a button in the interface that says Generate Theories. Now, this process is a huge, resource-hungry job that could take a long time. So how do you keep the user's screen from just freezing up and showing that dreaded spinning wheel while the computer is chugging away? And the solution is actually pretty clever. You just split that service in two. You've got an API app that immediately responds to the user's click. It just says, "Yup, got your request," and writes it down in a database. Then, a totally separate background jobs app sees that new task in the database and starts doing all the heavy lifting in the background. This leaves the user interface feeling super fast and responsive. But, as is so often the case in software, solving one problem creates a whole new one. What happens when you're not just dealing with a single user's click, but with thousands, maybe hundreds of thousands of tasks that all need to be processed? That simple background job model works great for a few tasks here and there, but for the core function of the system, which is churning through this non-stop fire hose of trading ideas, that's just not going to cut it. You need a dedicated, heavy-duty queue to manage all that work without anything getting lost.
And this gets us to one of the fundamental challenges in computing. If you've got a bunch of different workers all trying to grab a job from the to-do list, how on earth do you stop two of them from accidentally grabbing the very same job at the exact same time? That would be a huge waste of time, and it could totally mess up your results.
The solution they came up with is just brilliant in its simplicity. Instead of adding a big, complex new piece of technology, they just used the database they already had. They created two simple tables. Process queue is the master to-do list of every theory that needs to be checked, and active queue is like a temporary in-progress board, showing what's being worked on right now. Okay, so here's how the magic works. When a worker is ready for a new job, the first thing it does is put a temporary lock on that in-progress table. Then, it looks at the big to-do list and picks a task that isn't already on the in-progress board. It adds its new task to the in-progress board, and then it releases the lock. It's a super fast and basically foolproof way to make sure no two workers ever step on each other's toes. All right, so we've figured out how to hand out jobs without causing chaos. But what happens to a single one of those jobs, a single trading theory, as it goes through this long, complicated, multi-step validation process? How do you keep track of where it is in its journey? The answer is a concept that sounds kind of intimidating, but it's really not. It's called a finite state machine. All that means is that a theory can only be in one specific state at any given time, like new or being tested or passed or failed, and there are very strict rules about how it can move from one state to the next. It just brings a sense of order to the whole thing. So here's the journey our little theory takes, all managed by that state machine. First, it goes through a quick, broad test, just to weed out the really bad ideas. If it survives that, it moves on to a much deeper, more intense analysis. And if it makes it through that round, it gets a final, super rigorous validation. And only then is it either officially declared worthless, or it gets to graduate to the big leagues, the live trading system. So what's the big takeaway from all this? Well, this isn't really just about building a trading bot. It's about a way of thinking. It shows that by breaking down a massive, overwhelming problem into a series of smaller, deliberate, manageable choices, like monolith or microservices, background jobs or queues, you create a blueprint for tackling almost any kind of complexity. It really makes you wonder, what other huge problems could we solve with this same approach?
You know, when you hear trading bot, your mind probably jumps straight to some super complex financial strategy, right? But what if I told you the most crucial decisions aren't about finance at all? They're about engineering. Today, we're going to pull back the curtain and look at the hidden architecture, the real foundation that makes all of this automated trading stuff actually work.
So yeah, have you ever really wondered what's going on under the hood? And look, if you're thinking about those crazy algorithms, you're not wrong. But that's really only half the story.
The real magic
The stuff that makes sure the system is reliable and lightning fast, well, that's the architecture. It's this whole series of deliberate and, yeah, often pretty tough choices an engineer has to make before they even write a single line of trading code.
All right, so let's get into it. We're going to walk through the actual blueprint from a system architect, Victoria Delenjenko, and see exactly how a high-performance trading system gets built from the ground up, one critical decision at a time.
Okay, so where do you even start? First things first, you've got to pick your tools. The programming language, the framework, this is your foundation. And the rule here, the main principle, isn't about using the trendiest new tech. It's all about being practical. And this quote, it just nails the whole philosophy. The architect, Victoria, she knows C++ is a beast for trading bots, but she's not a C++ guru. And that's the key. The goal isn't to spend months learning a new language. The goal is to build a trading system. It's a super important distinction to make.
So why .NET then? Well, it just boiled down to some very specific, practical reasons. For her, it was just plain more convenient than C++. It handled data arrays and async code way better than TypeScript. And, a big one, it made writing automated tests a lot easier. The bottom line is she picked the tool that let her be the most effective, right here, right now.
Okay, tools are picked. So what's next? The next huge decision. How do you actually structure the code? Because believe it or not, no matter what you're building, every single developer starts in the exact same place.
With total chaos. You know how it is. You get an idea, you start hammering out code, and pretty soon, everything is just kind of connected to everything else. And this messy, unstructured approach, it actually has a name.
Yep, it's called spaghetti code, and it's exactly what it sounds like. A big, tangled mess. Everything is woven together, so if you try to change one little thing over here, you could break something totally unrelated over there. Sure, it's fast if you're just throwing together a quick prototype, but for something serious like a trading bot, it is an absolute nightmare to manage.
So, the very first step out of the chaos is separation. You can see it in this diagram here. We organize the code into these distinct layers. You've got your user interface up top, the core business logic, the brains of the operation in the middle, and the data access layer at the bottom. It's a massive improvement for sure, but there's still a problem. That business logic is still totally dependent on the database underneath it.
And that leads us to the solution, what's called clean architecture. Just look at how this diagram is flipped on its head. The domain, which is just a fancy word for your most important business rules, is now right in the protected center. Everything else, the UI, the database, all of it, now depends on the core. And this is a game changer. It means you can literally rip out your database and plug in a new one, or completely redesign the UI, all without touching a single line of your precious core trading logic.
But hey, even with a clean setup, you can still run into problems. Your different services can start talking directly to each other, creating this complicated web of calls. The answer to that is something called the mediator pattern. The best way to think about it is like an air traffic controller for your code. Instead of planes talking to each other, which would be chaos, they all talk to the tower. The tower then directs everyone where to go. Same idea here.
And here's how our architect likes to put it into practice. You don't make a complicated service call. You just fire off a simple command, like create new order, to that mediator. The mediator then goes and finds the one specific handler that knows how to deal with that single task. So each handler is small, it's focused, it's independent, it just makes the whole system incredibly clean.
All right, let's head down to the engine room. We're talking about data. Because in automated trading, speed isn't just important, speed is everything. We're talking about milliseconds making the difference between making money and losing it. And that reality forces some really tough decisions.
Just take a look at this trade-off right here. On one side, you've got a tool called Entity Framework. Super easy to use, tons of features, but it's a bit slower. On the other side, you've got Dapper. It's minimalist, it's harder to work with, but man, is it fast. For a high-frequency trading system, there's really no choice, is there? Performance has to win. And this quote just says it all, doesn't it? The architect is knowingly, consciously trading her own time and effort for the system's performance. She's basically saying, yeah, I'll spend more time writing code by hand if it means the bot runs faster. It's a choice that's 100% driven by what the project needs to succeed.
Here's another one of those pragmatic choices. Let's talk about data models. You could go with something called domain-driven design. Think of this like getting a completely custom, bespoke suit made.
It's going to fit you perfectly, but it's also going to be really expensive and take a long time. The alternative is the anemic model. This is more like buying a really nice suit off the rack. It's way cheaper, more flexible, and honestly, a much better starting point when you're not 100% sure what you need yet. You can always get it tailored later on.
Okay, so we've got our tools, we've got our architecture. Now for the fun part, how do we put this thing on autopilot? We need some kind of engine to run all those complex multi-step jobs that have to happen in the background all by themselves.
The core idea for managing all this is something called a finite state machine. Now, I know that sounds super technical and complicated, but the concept is actually pretty simple. All it means is that something, let's say a trade order, can only be in one specific state at a time, like pending or filled or canceled, and there are very strict, precise rules for how it can move from one state to the next.
This diagram gives you a great visual for how it works. See? An entity, like our trade order, enters the process. It moves to a step where it does something. Then, maybe it has to wait for an external event to happen. Once that event comes in, that's the trigger, it wakes up and moves to the next step. From there, it might make a decision that sends it back to do something again or moves it along until it's finally finished.
And the coolest part is that this whole potentially complex process is built from just 5 simple building blocks. You've got act nodes that do something, waiting nodes that just sit and wait, trigger nodes that react when something happens, terminal nodes that say, hey, we're done here, and description nodes which are really just for notes. That's it. That's the whole toolkit you need.
Now, for simpler jobs that just need to run on a schedule, there's another tool called the backworker. And the absolutely critical part of this, as you can see in the diagram, is this active tasks table. It basically acts as a lock. Why is that so important? Well, it stops 2 different parts of the system from grabbing the same task and trying to do it at the same time. You can imagine the kind of chaos that would cause.
So when you step back and look at all these decisions we've walked through, choosing .NET over C++, using that clean command pattern, picking the faster tool Dapper, building these automation engines, there's one single philosophy that ties it all together: pragmatism. It's all about making the smart, practical choice for the actual problem you're trying to solve, not just blindly following what a textbook says is correct. And that really leaves us with one final thought, one question for you. The next time you build something, what's going to be your guiding star? Are you going to chase that perfect textbook architecture, or are you going to focus on the pragmatic, real-world result that just gets the job done? It's a trade-off every single one of us has to make.
Today, we're going to dive into something pretty wild. A direct line from a biological theory from the 1800s to some of the smartest, most cutting-edge tech on Wall Street right now. Yeah, we're connecting the Galapagos Islands to the trading floor.
I know. Sounds a little crazy, right?
On one side, you've got Darwin and the slow, grinding process of natural evolution. And on the other, you have the hyper-fast, brutal world of high-frequency trading. What could they possibly have to do with each other?
Well, it turns out the answer is pretty much everything. The exact same principles Darwin discovered are the secret sauce behind a method for solving problems so ridiculously complex, they seem completely impossible.
Okay, so to really get why this solution is such a game changer, we first have to wrap our heads around the massive scale of the problem we're even trying to solve. And believe me, that's not just some poetic flourish. When you're trying to find one single perfect trading strategy among a practically infinite number of choices, the scale of that search is genuinely astronomical.
Every single parameter, every little rule, every condition you can think of, it just adds another dimension to the search. Trying to check them all off one by one, it's literally impossible. You just can't do it.
And the problem isn't just that there are a ton of options, it's that the whole search space is messy. The relationship between different settings isn't a straight line, so you can't just follow a simple path to the best answer. Instead, you've got all these different little peaks of good solutions, and it's super hard to know if you've found the absolute best one. Throw in the huge number of variables, and it becomes insanely expensive and time-consuming just to test one idea.
So, this is where we need a complete shift in thinking. A classic search algorithm gets bogged down testing one potential solution, then the next, then the next. It's just too slow. But a population search, it does something totally different. It creates a whole ecosystem of potential solutions, a whole population of them, and lets them all compete and evolve at the same time. So, if you can't find the best answer, how do you get to it? Well, the brilliant part is you don't find it, you grow it. And the blueprint for how to do this comes straight from Mother Nature.
And this isn't even a new thing.
Way back in 1975, a guy named John Holland basically formalized this. He looked at natural selection and realized, wait a second, evolution is the most powerful optimization algorithm in the universe. It's been running for billions of years, constantly finding incredible solutions to the problem of survival.
And this whole mind-blowing process really just boils down to 3 core ideas. 1. Heredity. Good traits get passed on. 2. Variability. You need differences. You can't have everyone be a perfect copy. And 3. The big one, natural selection. The weaker ideas get filtered out, and only the absolute best get to stick around and create the next generation.
Okay, that's the biology lesson. Now for the really cool part. Let's see how this blueprint gets translated from the natural world into the digital world of code.
Just think of this as our digital Rosetta Stone. It's the key to the whole thing. In this world, a complete trading strategy is like a chromosome. A single parameter inside that strategy, like a moving average period, is a gene, and the underlying code that defines the whole thing, that's its DNA. Once you make that mental leap, the entire process just clicks into place.
So we have this population of digital organisms, where each one is a trading strategy. So how do they actually get better? Well, it all happens through 2 key processes that are direct copies of biological reproduction.
The first one is mutation. This is basically the source of all new ideas. The algorithm goes in and makes a tiny, random change to one of the genes, one of the parameters. This is so important because it's how the population avoids getting stuck in a rut. It introduces brand new, sometimes brilliant ideas that neither of its parents had.
The second method is called crossover. Now, don't worry about the complex math on the screen here. The core concept is really simple. The algorithm finds 2 successful parent strategies and mixes their DNA together. The whole goal is to create a new child strategy that hopefully combines the best features of both parents.
Look, the source material for this gets way into the weeds with names like flat crossover or SBX, but you really don't need to be a math whiz to get it. All of these fancy operators are just trying to do 2 simple things: create totally new ideas and combine the best ideas you already have. That's it.
So we're creating new ideas, we're combining old ones, but how does the algorithm figure out which ones are actually the fittest? This is where the digital version of natural selection really shines.
One of the most common ways to do this is with a method called the roulette wheel. It's such an elegant way to simulate this whole survival idea. Basically, every single strategy in your population gets a slice of a virtual roulette wheel. And the rule is simple. The more profitable a strategy is, the bigger its slice of the pie. And then you just spin the wheel. Whichever strategies it lands on are chosen to be the parents for the next generation. You can see how this works, right? The ones with the bigger slices, the more profitable ones, just have a much higher chance of being picked to pass on their genes. It's not a guarantee every single time, but over thousands and thousands of spins, the fittest strategies absolutely win out. And this ties the whole thing together into one powerful, continuous loop. You start with a totally random population of strategies. You test how good they are, their fitness. Use the roulette wheel to select the best of the best. You let them breed to create a new generation. And then you just do it all over again. And this right here is the absolute magic of it. It's a system of relentless automated improvement. Sure, any one individual child strategy might be a dud, but the population as a whole, on average, just keeps getting stronger and smarter and better adapted to its environment. In this case, that environment is the market. So think about that. This all started with Darwin watching finches on an island, and now it's running on servers trying to master Wall Street. This approach isn't just for trading, it's a fundamentally different way to solve problems. And that leaves us with one last big question to chew on. If code can evolve to beat one of the most complex systems we've ever created, what other impossible problems are out there, just waiting for the right kind of evolution? All right, picture this. You're trying to find the single best, most profitable automated trading strategy out there. The thing is, you're not just looking for a needle in a haystack. You're looking for one specific needle in like billions of haystacks. So how on earth do you even start? Let's get into it.
Yeah, this is really the multi-billion-dollar question, isn't it? It's what drives the whole world of quantitative trading. We're not just trying to find a good strategy, one that kind of works. We're hunting for the absolute best one out of a massive ocean of possibilities. So how can a computer possibly sift through all of that to find the winner?
So why is this so hard? Well, it all boils down to one thing:
Parameters. See, every single automated trading strategy is built from a bunch of these parameters. And if you change just one tiny little thing, you've created a totally new strategy. Do you see where this is going? The number of possible combinations just explodes into these, well, astronomically huge numbers.
Okay, take a look at this. It might seem simple, right? Just 4 little parameters, but here's where it gets crazy. You're not just adding these options together, you're multiplying them. And we're talking about multiplying hundreds by hundreds. And suddenly, you're looking at millions or even billions of unique strategies. That search space just becomes unbelievably vast almost instantly.
All right, so you've got this gigantic, almost impossible problem. What's the first thing that pops into your head? You know, the most obvious, direct way to tackle?
Well, that straightforward approach has a name, the brute force algorithm. And yeah, the name pretty much says it all, doesn't it? It's not about being clever or elegant, it's about raw computational power. The idea is just try everything.
So think about it like this. Imagine you have a keychain with billions of keys, and only one of them opens a lock. The brute force method is literally just trying every single key, one by one, until you hear that click. It's super thorough for sure. It will eventually find the answer, but you can probably already guess the massive downside, right? And here's the bottom line. While brute force is simple to understand, it is, well, it's crushingly slow. I mean, testing billions of strategies could take years, maybe even decades. That's just not practical. We need a smarter way, a more efficient way to search. And for that, we're going to look for inspiration from the best problem solver we know, nature. So instead of trying every single key on that giant keychain, what if we could evolve a better key over time? This is the amazing idea behind something called a genetic algorithm. It's a really powerful technique that actually mimics natural selection to solve these kinds of incredibly complex problems.
And this diagram just shows it perfectly. It's all about a feedback loop. See, the algorithm generates a whole batch of strategies, then a calculator tests them out to see how they do. The results get fed back, and the algorithm uses that information to create a brand new and hopefully much better batch for the next round. It's literally learning and improving, cycle after cycle.
You know, this is what makes genetic algorithms so incredibly powerful. It's not some strict, rigid set of rules you have to follow. It's more like a toolkit, a set of instructions you can use to build your own custom variations. You can mix and match different parts to create an optimization engine that's perfectly tuned for whatever problem you're trying to solve.
Okay, so how does this whole evolution thing actually work inside a computer? It sounds complicated, but we can actually break the whole process down into 4 basic steps that just repeat over and over in a cycle.
First up, initialization. You've got to start somewhere, right? So the algorithm basically just throws a bunch of darts at a board. It generates a population of completely random strategies. We call this generation 0. It's messy, it's chaotic, but it gives us the raw material we need for evolution to begin.
Next, we have mutation. This is where the algorithm injects a little bit of controlled chaos into the mix. It'll randomly go in and tweak a few parameters, the genes, in some of the strategies. Now, this is absolutely crucial. It's what stops the algorithm from getting stuck on a single bad idea and forces it to explore brand new and maybe even much, much better possibilities.
Step 3 is filtering, and this is pure survival of the fittest. The algorithm backtests every strategy in the population. Basically, it runs them against old market data to see how they would have done. The ones that fail, the ones that lose money, they're out. They get discarded. Only the top performers, the truly fittest strategies, get to survive and move on.
And finally, step 4, breeding. You might also hear this called crossover. Here, the algorithm takes the best strategies that survive the filtering step and, well, it breeds them. It combines their parameters, their genes, to create new offspring strategies. The whole idea is that these new offspring will inherit the successful traits from their parents, hopefully creating an even more profitable combination.
Okay, so those are the 4 steps. But the real magic, the real power, comes when you put them all together. This isn't something you just do once. It's a continuous cycle of getting better and better.
So the algorithm just keeps looping through those steps, mutation, filtering, and breeding, over and over and over again. And with each cycle, or generation, the whole population of strategies gets a little bit smarter, a little more refined, and a whole lot closer to that perfect solution. It's intelligently evolving its way to the needle in the haystack, without having to check every single piece of straw along the way.
So you might be thinking,
Okay, that's cool for trading algorithms. But why does this matter to me? What's the big takeaway here? Well, this whole approach represents a massive shift in how we solve really complex problems. I mean, think about it. The takeaway here is huge. Instead of trying to design a perfect solution from the ground up, we're using a process that nature itself has been perfecting for billions of years: evolution. This lets us tackle problems that are just way too big and complicated for brute force methods. And because it's so modular, it's not just for finance. We're seeing this kind of thinking optimize everything from delivery routes for shipping companies to the design of more efficient jet engines. It's everywhere.
And that really brings us to a final mind-bending thought. We've seen how this method can find that one needle in a billion haystacks. So if an AI can literally evolve a solution for a problem this complex, what other challenges, what other things that we think of as impossible today are just waiting to be solved next?
You've probably heard of automated trading systems, right? They're these powerful, super fast brains making huge financial decisions in microseconds. But for most of us, they're just a complete black box. Well, today, that's exactly what we're going to do. We're going to crack this thing wide open and see how the logic inside actually works.
Okay, so let's dive right in. You see this picture? Market data goes in one side, and commands to buy or sell come out the other. But what is happening in the middle, inside that box? We're about to look at the core module, the central processing unit, the actual brain of the whole operation.
So at its heart, the core's job sounds pretty simple, right? It just looks at a constant stream of market data and decides, should I send a buy command or a sell command? That's it. But how it gets to that decision, well, that's where things start to get really fascinating.
And here's what's so cool about this particular brain. It's incredibly versatile. See, it's not just making live trades with real money. It uses the exact same logic to test out trading theories on data from the past. So it's kind of like a history professor and a fighter pilot rolled into one.
So that brings us to its two main modes of operation. First, it plays the role of a historian, digging through mountains of old data, trying to find strategies that actually work. And then it switches gears and becomes a live trader, using those proven strategies out in the real world.
And this slide really shows you the two different personalities of the core. On one hand, you've got the historical analyst, looking for patterns in the past to try and predict the future. And on the other hand, you've got the live market operator, making those split-second decisions right here, right now.
Let's start with what we can call the flight simulator mode. This is where the core tests strategies against history. It loads up a bunch of past data, makes pretend trades, and keeps track of every single outcome to see what would have been profitable. And the best part? It's all done without risking a single penny of real money.
All right, so after all that testing, once we found a winning strategy, it's time for the live flight. The system flips the switch to real-time data, and that very same core logic starts making decisions that send actual buy and sell orders out into the market. So you might be wondering, what actually kicks this whole process off? Whether it's in the simulator or in the live market, what's the one single event that makes this digital brain wake up and start thinking? And the answer is this little thing right here, a candle. Seriously, think of it like a heartbeat for the market. It's just a neat little package of data that wraps up everything that happened. The high price, the low price, where it opened, where it closed, over a set period of time, usually about 1 minute. And that right there, that's the trigger for everything. Every single time a new 1-minute candle arrives, the core module sparks to life and runs its entire decision-making process from top to bottom. It's this constant rhythmic pulse. Analysis, analysis, analysis. Every single minute. Okay, so this is where it gets really fun. Let's look inside and see how the core actually translates the raw numbers from that candle into a simple yes, trade, or no, don't trade command. At the end of the day, all of this complicated math and logic, it all boils down to one simple thing: producing a signal. That's it. The entire pyramid of logic is built just to answer one question. Should we open a position or should we close one? Just a simple yes or no.
So how do we get to that final yes or no? Well, the best way to think about it is like a recipe. The final signal, that's the finished dish itself, the instruction to bake the cake.
But, you can't just bake the cake. You need the steps, right? In our system, these are the condition groups. A group might require that all of its rules are true. You have to preheat the oven and mix the ingredients. Or it might only require that one of them is true. And each of those groups, It's made up of even smaller pieces called conditions. These are like the most basic ABC building blocks of the whole recipe. It's just a simple true or false question, like, is the oven temperature greater than 350 degrees? And finally, at the very bottom of our recipe, you've got the raw ingredients. These are the indicators. These are the actual numbers and calculations that come from the market data, things like momentum, moving averages, or as we're about to see, market volatility. Okay, that might sound a little abstract, so let's make it real. Let's look at one of the most common ingredients you'll find in these trading recipes, the average true range, or ATR. It's a classic way to measure how much the market is jumping around, its volatility. So, it all starts with something called the true range. The system looks at just one candle and uses a formula to figure out the absolute biggest price swing during that minute. It's a clever way to capture the full price swing, even if the market jumped from the minute before.
Now, looking at just 1 minute can be kind of jumpy, right? A little noisy. So what the system does is it averages that true range value over a bunch of past candles. And what you get is the ATR, a much smoother, more reliable picture of how volatile the market is right now.
All right, so let's pull back and put all these pieces together. We have the trigger, that 1 minute candle, and we have the ingredients, like volatility. Now we can trace the entire chain reaction, from a single pulse of market data all the way to a final trading command.
And boom, here it is, the entire chain reaction, laid out from start to finish. A new candle arrives. That triggers all the indicators to get recalculated. Those new values are checked by conditions. The results from those are combined in condition groups, which then produce a final signal. And if that signal is a yes, a command gets sent out.
And just remember, this entire logical cascade, from raw data all the way to a final decision, it doesn't take minutes or even seconds. It happens in a tiny fraction of a second. And it does this over and over and over again every single minute, all day long. So we've just peeled back the layers on one of these automated trading brains. And it makes you think, across all the world's financial markets, how many thousands, maybe even millions of these logical brains are firing off decisions right now, shaping the markets, shaping our economy? It kind of makes you wonder, doesn't it? Hey everyone, and welcome. Have you ever looked at a massive app on your phone and just wondered, how did that start? How does a single piece of code become this huge global thing that thousands of people can use at once? Well, today we're going to pull back the curtain on that exact journey. We're taking a simple trading app and following its path from a developer's laptop all the way to the cloud, making it tough, scalable, and ready for anything. And really, it all boils down to this one question. You've built your app, right? It runs perfectly on your machine. But how in the world do you prepare it to handle a ton of users without just falling over? How do you push out an update without taking the whole thing down? The answer, and this is our roadmap for today, is a really cool 3-step metaphor: box, fleet, and blueprint. It's simple. First, we're going to put our app into a self-contained box. Then that box is going to join a whole fleet of other boxes so they can be managed as one big team. And finally, we use a reusable blueprint to deploy that entire fleet. So remember that. Box, fleet, blueprint. Let's get started with the box.
So our journey starts with what we'll call the seed, the application code itself. And the very first thing we have to do to get it ready for the big leagues is a process called containerization. This is how we build our box.
So what's our little seed application? It's a pretty straightforward adapter for the Binance crypto exchange. All it does is connect to Binance, grab that real-time price data, the candlestick charts you see, and then it pipes all that data into a high-speed messaging system called Kafka. From there, other parts of the trading system can use it. It might be small, but it's a super critical link in the chain. Now, back in the day, you'd probably just throw this app onto a server, a virtual machine, right alongside a bunch of other apps. And you can probably already see the problem. What happens when one app needs Python 3, but another one needs .NET 6, and a third one needs an even newer version like .NET 8? It's a total mess. You get into this nightmare of conflicting software versions. It's just a headache to manage.
And this is where containerization comes in to save the day. Think of it like creating a perfect little isolated bubble for our app. We literally bundle the code with everything it needs to run, the right libraries, the right software versions, every single file. This package, this container, becomes our box. And the beautiful part? It's totally portable. It'll run exactly the same way everywhere, whether it's on my laptop or on some giant server in the cloud. And the go-to tool for this is, of course, Docker.
The whole process is surprisingly simple. You install the Docker software, you write a plain text file called a Docker file. That's basically the recipe for your box. Then you type docker build to create the package, which is called an image. And finally, you type docker run to fire it up. That's literally it. Our app is now snug inside its box.
Okay, so we've got one box. But a real-world trading system can't rely on just one. For one thing, it's not reliable. We need a whole bunch of them running at the same time to handle all the users. And, well, trying to manage a whole fleet of these things, that brings a whole new set of problems.
And this right here is where things get really interesting. See, running one container, easy. But a whole fleet? That's a completely different ballgame. How do you update hundreds of them at once without any downtime? How can you even tell if one of them has crashed? A single container is a single point of failure. A fleet? Well, a fleet needs to be able to heal itself. It needs to automatically scale up when traffic is heavy and scale back down when it's not. Trying to do all that by hand? No way. It's just not possible.
This is exactly why we need a fleet commander. We need a system that's built from the ground up to automate and manage our containers at a massive scale. This kind of tool is called an orchestrator, and the undisputed king of orchestrators is Kubernetes.
So this is what a Kubernetes system looks like at a high level. It's called a cluster. You've got a master node, which is basically the brain of the whole operation, the commander. It's making all the decisions. And then you have a bunch of worker nodes. These are the servers that are actually doing the heavy lifting, running our app containers. The master tells the workers what to do, and the workers just do it and report back. Simple as that.
Now, in the world of Kubernetes, our container doesn't just run on its own. It's placed inside something called a pod. It's a bit of a funny name, I know, but you can just think of a pod as the smallest, most basic unit of our fleet. It's just a little wrapper around our container that gives it an address and lets Kubernetes keep track of it.
So if pods are the workers, who manages them? That's the job of a deployment. A deployment is basically where we tell Kubernetes what we want our world to look like. We say something like, hey Kubernetes, I want 2 pods of my Binance adapter running, always. And the deployment's job is to make sure that's true, 24/7, no matter what happens.
And the last piece of the puzzle, how does anything actually talk to our app? They use what's called a service. You can think of a service like a single, permanent mailing address for our application. Behind the scenes, pods might be starting or stopping, but that service address never ever changes. It intelligently routes traffic to whichever of our pods are healthy and ready to work. It's absolutely crucial. All right, so let's see it all in action. Here's our system in a perfect, healthy state. Our deployment says we want a target of 2 pods. And sure enough, Kubernetes has given us pod A and pod B. Everything is humming along nicely. But, we live in the real world. Things break. Servers go down. Apps have bugs. So what happens if, all of a sudden, one of our pods just dies? And here it is. This is the magic of Kubernetes. The moment pod A terminates, the deployment controller notices. It says, whoa, wait a minute. My actual state is 1 running pod, but my target state is 2. So what does it do? It instantly, automatically spins up a brand new pod, pod C, to take its place. The system literally heals itself, usually before a human even knows anything went wrong. Pretty amazing, right?
So at this point, we've boxed up our app and we've put it in a fleet that can heal itself. We're in great shape. But what if we have, say, a dozen apps that are all really similar? One adopter for Binance, another one for Kraken, another for a stock exchange. Writing all those complicated Kubernetes files over and over again, that's going to be tedious and super easy to mess up. We need a blueprint. So how do we make a blueprint? We'll take a look. On the left is a normal Kubernetes file. See how everything is hard-coded? The name says Gateways Binance. The port is 1234. Now look at the right. This is a template using a tool called Helm. Instead of hard-coded values, we've got these little placeholders, these variables. This turns our configuration into a reusable blueprint. Now we can deploy any gateway we want with a single command, just by plugging in different values for those placeholders.
So let's take a step back. We've gone from a single file of code to a container to an orchestrated fleet, all managed by a reusable blueprint. Why on earth did we go through all that trouble? What's the big payoff?
In the end, this whole setup gives us 3 superpowers. First is scalability. If we need to handle more traffic, we just tell Kubernetes we want more pods. Done. Second is independence. Because every service is in its own isolated box, if our Binance adapter has a problem, it's not going to crash the entire trading system. And third, and maybe most importantly, is automation. Updates, health checks, scaling, recovering from failure, it's all handled for us automatically by our fleet commander.
And that really brings us to the final idea here. The crazy infrastructure we just walked through, it isn't really the end of the story. It's the foundation. As the source material so perfectly puts it, building these kinds of complex systems is a journey, not a destination. There's always room to make things better. And this powerful, flexible stack, Docker, Kubernetes, and Helm, is what gives developers the tools they need to build, to adapt, and to keep on improving endlessly.